So in today's lecture, we are going to see the insertion of elements into a linked list. In past lectures, we have seen what is a linked list, what is the structure of it, how the nodes are defined, how the linked list can be created, and how it can be displayed. We have also tried a program on that. Now, there are few main operations which will be performed on a linked list. These operations are insertion of a node in a linked list, deletion of a node in a linked list, and traversing a linked list from first node to the last node. These are the main operations which we are performing on the linked list, and that's what we are going to see. Being linked list as a dynamic data structure, definitely we have a liberty to insert the elements in that in at any point of time, at any place, and also we can delete the elements from at any point of time and from any place. So we are in today's discussion we are going to see insertion of an element in a linked list. So if I'm considering this as a linked list, this is the head node, which is very important. We need to keep the address of it, because with the help of that only we are going to traverse the entire list. So it is possible for me to insert the element at the end. It is possible for me to insert the element in the beginning, and also it is possible for me to insert the element in between or at a particular position in the linked list. May it be third position, fourth position, or so on. Okay, so there are three operations we are going to see: insert the element at the beginning of the linked list, insertion of the element at the end of linked list, and insertion of the element in the at a given position in the linked list. We are treating this insertion as three separate functions which are applicable for insertion of a node at a particular position in the given linked list. So one by one, we will see how these elements will be inserted. So let us start with the first one, that is insertion at the beginning. Let us try to insert the element at the beginning. Then how you can do it? While creation of a linked list, you have seen when the element is coming into picture, what we are going to do? We are going to simply create a new node. It may be created at any location, any memory place, and the data field will be filled with that element, and its link field will be set as null, and then we are appending that node at the end of linked list. So ultimately that is also insertion, but it's a creation of linked list. And once here, this case is once the linked list is created and already functioning, we are trying to insert a node at the beginning of that list. So we are trying to make the node the first element of the list. So how we can do it? So let us say that we are going to insert a node with value 20 at the beginning. So a value given is 20. That means data field of that node will be 20. So when you want to insert a node, it's very simple. Create the node and store the data first. So we can just create a node with malloc function. We can very easily do it and make its data as 3. Sorry, not 3. It should be 20. Make it 20. Okay, and let us name that node as new. Let us name that node as new. So once this node is created, we have initialized the data position as 20, but main role in a linked list is of pointers. So as I said earlier, when we want to insert an element or a delete an element, ultimately we are going to play with the pointers in the linked list. Now when I am treating this as the first node in the linked list, I want to treat this as a first node in the linked list. What we can do, or what we are supposed to do is, if it is the first node, now this should point to the first node of the existing linked list. So, or we can say point to this particular node. Am I right? This is the existing first node. Now this new is going to become the first node. Now we need to establish this link first. Okay, how this can be established? I can just make new dot link is equal to head. Where head is pointing? Head is pointing to the first node of the list. So these two address fields will become same, and I'm going to store 3200 in this case. Okay, now this node is going to point to the first node, existing first node of the linked list. But now the new node is going to act as the first node, and the existing first node will be the second node of the linked list. So we'll modify head to this address. Let us say that it is stored at say 4200. So once we are trying to change the address of head, this head will become now 4200. Head is going to point to 4200. So you are going to traverse the list as 20, 15, 3, 17, 19. And we are going to, as soon as we have initialized or we have assigned the address 4200 to head, this link is vanished. And head will point to the new node, which will become the first node of the linked list. Okay, this way we can insert a node at the beginning in the linked list. How can we do it further? We'll see. As an algorithm, how can I treat this? So there will be the first step. Allocate memory for a new node. As soon as the new element has come and I want to insert it as the first node, first we'll have to create that node. So allocate memory for the node. With the help of malloc function, we can do it. So we are going to create a node named as new node of type link node. Then store the data into that. So we are going to make it new node is equal to malloc size of struct node. Do I really need to explain this? We have already seen this. Okay, malloc will be a function which will allocate a specified size of memory in the main memory. Okay, so that piece will be allocated. The size of that piece is struct node size, and it is assigned to the pointer new node. So now a new node is created this way. Nothing is right now assigned in that, and the address 4200 will be stored in new node. So new node is going to become 4200. Okay, after malloc function. I'm telling it after malloc function. And new node dot data is 4. Any value. Means here in the example it is taken as 4. I can make it as 20. So new node data is 20. It is not a very important part as far as the insertion is concerned. Okay, so we have stored the data in the data field of new node as 20. This is the second thing which we did. What next we are supposed to do? Now we need to manipulate the pointer. Now the pointer, change the next of new node, change the next field of new node to point to the head. Okay, that means the data field of new node is 20 and link field of new node is head. What is head? Head is the address of first node in the data. That's what we are trying to create this link now. We are trying to create this link. Okay, this link, which we have already created in the diagram. Okay, so change this to the new node. And what next? Simply change head pointing to the new node. So change head to point to the recently created node. Okay, now head will be pointing to the recently created node, that is new node, and it will become the first node. So it will be happening in this way. So this piece of code can definitely get you the how the node should be inserted in this. In this, I am assuming that you know what is the structure of a node, how it is defined, how the pointers for it are defined, how malloc works. I am taking it as granted that you know all these things. If you don't know, you please go through the previous lecture and then only try to go through this lecture. Otherwise it will not be clear to you. Okay, so simply we have allocated a memory, created a node, allocated a memory, changed its data field, changed its link field pointing to the first node of the existing first node of the list, and then make the head node point to the new node. Thus new node become the first node of the linked list. Okay, so this is the first function where we are inserting the node at the beginning. Going for the next case, that is inserting the node at the end. Inserting node at the end is very similar to create a linked list. In creation of linked list we are going to do the same, but in this case only difference is we have to first reach to the last node. First we'll have to reach to the last node. So let us say that again some data is coming into picture. Let us say that data 4 is coming into picture. How we are going to insert the element? Very simply, first create a node, named as new node. We'll name it as new node. Okay, and then make that data field is equal to 4. So create a node, make the data field as node. Let us say that it is stored at location number 5000. Okay, now as it is going to be inserted as the last node, what will be the link field of last node? Always it will be null. So make this link field as null as it is reaching as it is getting appended as the last node. So this node is created. Now what? I need to insert it at the end of the list. Then I need to first traverse the list till I get the last node. What is the indication of last node? The node which is having link field as null is the last node of my uh, linked list. Okay, so I need to traverse the list one by one till I reach to the list, to the node which has its link field as null. Okay, so if I'm going to 3200 head, and with head I can traverse the list. What I'll do, I'll create one more pointer called as, let us say that temp, how I'm traversing a list. So I'm making it as temp. Temp is equal to, right now pointing to head, means it will point to the first pointer. Okay, and we'll just check if temp dot link is equal to null or not. If it is not, then go to the next node. Whether temp dot null is temp dot link is the null, no, then make temp is equal to temp dot next. Make temp is equal to temp dot next. So temp dot next. Temp dot next. I'll just erase this. It's not visible to you. So temp will be changing to temp dot next. Means what will happen? Temp will now point to the next node. See, temp is also a pointer variable, huh? As we have head. So now temp will point to this node. Check if it is null. No. Again traverse. Check if it is null. No. Again traverse. Check if it is null. Yes. At this position, temp dot next is equal to null. So if it is temp dot next is equal to null, we are going to make it as 5000. We are going to make it as 5000. Just a moment. So one by one, now what will happen is we are going to, now we have reached to the last node of the linked list, and now this last node should point to the new node. So this link has to be created. So how it can be created? By making temp.next, because temp is right now that time pointing to the last node. Temp.next is equal to 5000. So this way it will be added to the node. Okay, added to the linked list at the end. So this way we can insert the elements in the last node of the as a last node of the linked list. Let us see it in an algorithm format. First, allocate the memory for new node, which we did. The name is given to it, can be done in this way. Store the data. So these are the things which we are doing. Storing the data means we are allocating it with malloc, for saying it as a new node, making its data as 4 and next field as null, because it is going to be added as the last node, hence its link field will be can be made as null directly. Now traverse to the last node. This is very important part in this particular algorithm. How we can traverse to the last node? We can traverse to the last node in this way. We are making a new pointer temp which will hold the value of head initially. It will point to the first node, and one by one it will locate till the last node. There is a possibility that head itself is null. There is no list in existence. Okay, that possibility also will have to work. So, but we are not saying that, we are assuming that there is a list in existence. So while temp.next is equal to null, is it? No. If it is no, go on traversing till temp is equal to temp dot next till you get the next field as null. That's what we did in this case. We traversed from 15 to 3 to 17 to 90, and at 90 we got that it is null. So once you have reached that node, very simply change the next of last node to recently created node. Okay, that if once you have got temp.next is equal to null, that means you have reached to the last node. Now change the next of last node, next field of last node, or the link field of last node to the recently created node in this way. Okay, so this is the second type of insertion we are doing, that is um, insertion at the end of linked list. Fine. I hope you are understanding what we are doing. Now the third case, which is a little tricky or complicated, or more number of pointers we need to deal with, is insertion at a particular position. Means as a second member, as a third member, as a fourth member, and so on. Okay, we'll have to so we'll have to insert the element in between two nodes. How it can be done? So what is possible? Let us say that again we'll take the first example, that let us insert 4. Data element 4 has come, and I need to insert at position number 3. I am given a task of inserting that as a third member of the list. So we are going to create a node as usual, make its data field as 4, name it as a new node, and let us say that it is getting stored at location number 5000. This is a normal allocation we are doing. But now it's not the case of last node where we are making its next field as null. Now if I want to insert it as the third node in the list, the existing third node is going to become the fourth node. First I'll have to reach to the node just immediately previous to the position which I have specified. So if I am inserting the node at third position, I need to reach to the second position. I need to reach to the second position. So let us maintain a count. Let us maintain a count. Okay. So count will be initially 0. Okay, is pointing nowhere. Now I will take a variable temp. Again, temp will hold the address of head. And if head is not equal to null, I am going to increment count as 1. So make count as 1. Because temp is now pointing to the first node. Okay, temp is pointing to the first node. Then I will traverse the list till I get the position -1 place. Okay, position -1 place. So what will happen next? I will traverse till temp, traverse as temp is equal to temp dot next till you get count is equal to position -1. In this case, count is equal to 2. So you are going to traverse the list till you get count is equal to 2. Once you got count is equal to 2, that means the next node can be the in the third node. The next node will be the third node, and at that position I can insert the element. So your temp is going to point here. Temp is going to point here. What next we can do is, now at this position, once we have reached to this particular location, this pointer, this node should point here. Am I right? And this should point here. And this link need to be destroyed. So what will happen now? 15, 3, 4, 17, 19. So in insertion at a particular position, we are destroying one link and creating two new links. Okay, but the sequence of creation of these two links is also very important. I'll erase this and again we'll go for what we are going to do. Sequence of important. Say that now we are so first we'll have to store this address. This address is the address of this node. Okay, but now this should point to this node. This should point to this second node. Temp should point to the newly created node. If I am creating this link, this new link first, if I am creating this link here, the address value will be changing to 5000. Address value will be changing to 5000. Address value will be changing to 5000, and I'm going to lose this address. I'm going to lose this address. So it should not happen. So first you need to create this link, and then only you go for the next link. So this is the node. So we need to first create this link. How I can create this link? New.next is equal to temp.next. This address need to be stored here. I'll write here 4000. Right? And then I can create this link. And I can change this address to 5000. So now the list can be 15, 3, 4, 17, 19. So sequence of creation and destruction of list is important. So ultimately when I create this link, I also have the same address in this particular node. Then I change this link, I create this link, automatically this link gets destroyed. Okay. If I am creating this link first, this link will get destroyed and I won't be able to create this link because I'll lose the address of this. So this is little crucial, not very difficult to understand, but you need to be very clear regarding this. So how it can be done in an algorithmic format. Those who have not understood, please scroll back and again try to listen what is being told. we'll go for the algorithm. So allocate the memory and store the data for the new node, which in every case we are doing. Okay, so a new node is created, its malloc function is executed, and now data is equal to 4 is stored into that. What next? Traverse the node traverse to the node just before the required position of the new node. So if it is 3, we need to travel to 2. If it is 4, you need to travel to the third node. That way. We are taking very small example of having 3 or 4 nodes only. The linked list will be generally maintained for 10,000, 20,000 or lakhs of nodes together. Now we have to reach to the just previous node, to the position where we are supposed to insert the new node. We are using a temp variable. Now we are starting I is equal to 1. As soon as temp is pointing to head, it should be going to 1. So I am not going in the formalities of I is equal to 0 or something like that. Right, directly we are writing I is equal to 1. Here the declaration is done at this position only. So I is equal to 1 means temp is pointing to the first node, to the position number 1. Until how long we are going to increment? Till I is less than position, just less than position. So position minus 1. Position minus 1. Till that point we are going to scroll I plus plus. What we are going to check? We'll have to also check whether the position specified is correct or not. If in this list I'm saying that insert at position number 10, it won't work because it has only 4 nodes. So that's what that thing also we are taking care of. So if temp.next is not equal to null, then only you proceed. If it is null, then we are going to print a error message. So I'm not writing that, but that provision also you can do. So go on temp is equal to temp.next, and now change the next pointer to include new node in between. So how we can do it? We can do it in this way. New node dot next is equal to temp dot next. Just now what I said. Okay, you are going to create this link first. Okay, so new node dot next is equal to temp dot next, and later you are going to change temp dot next to the new node. Now we are creating this link. Okay, so this way a insertion of a linked list at a particular position can also be done. This will mainly be used when you are using a sorted linked list. When your linked list is sorted, and at most of the cases you'll have to insert it in between. Unlike arrays, in arrays, if you are inserting it in between, you are going to shift all the latter nodes one position down. But in this case, it is not needed. All will remain at their position. Only link field of previous and next will be changed. Even not next, the new will be changed. In this way, we can insert the nodes at first position, last position, and at a particular given position. So when you are trying to write a program, we have already written a program. We have already tried a program to create a node, create a linked list and display it. Now you can go on adding the functions. So you can write 3 separate functions for 3 separate insertions. Insertion at beginning, one function. Second function, insertion at end, and third function, insert at a position. So you'll have to write 3 different functions for all these 3, and because every time little functionality is changed, so you can modify your program. You can extend your program to accommodate these 3 insertion algorithms also. Okay, so I hope you have understood this, and we'll stop here today. In the next lecture, we are going to see deletion of the linked list, node in the linked list. Thank you very much.